In this series, I'll be summarizing the chapters of the popular book, Reinforcement Learning, an Introduction by Richard S. Sutton and Andrew Barto. I'll also be providing code examples of each of the algorithms in Python, so hopefully this will be useful to you if you're just getting started with RL or looking to gain a deeper understanding. In this video, I'll be covering Chapter 1, which is just a brief introduction to RL. So first off, what is reinforcement learning? Reinforcement learning is simply learning how to maximize reward through trial and error. And every RL problem has a few different key components. The first component of any RL problem is the agent, which is simply the thing that is acting. For example, in a video game, it could be the character, like Pac-Man, or in robotics, it could be the robotic arm, etc. It's just the thing that's acting. The next key component of an RL problem is the environment, which is where the agent is acting. This could be a video game like chess, in which the agent is able to observe the positions of its own pieces as well as the positions of the opponent's pieces. For things like self-driving cars, their environment could be the real world, in which the agent, which is the car, is able to observe traffic signals, pedestrians, and other cars. The next key component is the state. States are simply another word for the observations returned from the environment. In the chess example, a formal representation of the state of the game might be a list of all the pieces and their positions on the board. Arguably, the most important part of any RL problem is the reward, which defines the goal of the problem. The reward is given to the agent from the environment to encourage or punish certain behaviors. A chess agent could get small positive rewards for doing things like taking opponents' pieces, and a big positive reward for winning the game. And a self-driving car could get negative rewards for doing things like crashing or disobeying traffic laws. While the reward defines what's good in the short term, value functions define what's good in the long term. And they do this by calculating the value of being in a particular state from the perspective of maximizing cumulative reward, which is the total reward that the agent will receive over time. In complex environments, it may be better to forego short-term rewards in exchange for greater longer-term rewards, similar to like delayed gratification in real life. And value functions help capture all of that. The agent has to have the ability to influence the environment, and it does so by taking actions. An action could be moving a game piece to a new position on the board, or in the car example, it could be increasing the velocity of a car, or in the robot example, it could be changing the angles of one of the motors on the robot arm, or something like that. It just gives the agent the ability to influence the environment. The policy defines the way that the agent behaves. So it defines, like, given an observation from the environment, what actions should the agent take? And as the agent gains experience, it tries to improve its policy to get greater cumulative rewards. Now that you understand the basic components of RL, you might be wondering how it differs from other forms of ML, such as supervised learning. The key difference between reinforcement learning and supervised learning is that RL deals with learning from experience, while supervised learning deals with learning from labeled examples. And the purpose of supervised learning is for a system to generalize its responses such that it acts correctly in situations that are not present in its training set. The reason that supervised learning can't generalize to the interactive problems that we use in RL is that with interactive problems, it's often impractical to get examples of desired behavior that are both correct and representative of all the situations in which the agent has to act. And since we can't get these labeled examples, we have to use alternative methods like RL instead. In uncharted territory, an agent must be able to learn from its own experience. RL is all about maximizing reward, as opposed to unsupervised learning, which is about finding structures in unlabeled data. So that's the difference between RL and unsupervised learning. And finding the structures in labeled data can be useful, but is definitely not sufficient for solving a RL problem. That concept of reward is really necessary and what distinguishes RL from other forms of machine learning. So now that we understand the basics of RL and how it compares to other forms of machine learning, in the next video, we'll take a look at a simple version of a RL problem.